So in the past video, we were asked to determine the point of contraflexure. And we said this is the point where the bending moment diagram changes sign, changing from positive to negative. That point is very important for us, and we have seen that according to this bending moment diagram, it is taking place between D and C. So this point is here where the bending moment diagram, this curve is going to negative. So we need to know what this point is and where it occurs. So now we have our free body diagram with all the forces indicated. What we are going to do, we are going to put a section at this point between D and C, anywhere between D and C, and between D and C, but of course behind B, because we see this point happens before point B. It occurs before point B. So we have to make sure that it's between D and C, but behind B or before B. So what we do, if we indicate a distance y from C and put a section there, we will need to determine the bending moment at this point. So we can use this side so that we have a shorter equation and easier to solve than having several of these forces. If we take the bending moment of this side for this particular section of C to Y, then we will have the only forces acting will be the 19, the 2 kilonewton, the bending moment that we have indicated as an internal load. Then we will also have this load or the forces due to the uniformly distributed load. The 19 kilonewton will be acting in an anti-clockwise direction. The 2, then the bending moment and the uniformly distributed load will be acting in a clockwise direction, and that's why I'm making them positive. So MYY plus 2Y, because 2 is at a distance Y from section YY, and then minus 19 into Y minus 1, because from here to here is Y, and from here to here is 1, so from here to here is Y minus 1. Then plus we see that also the uniformly distributed load is of magnitude is of 4 kilonewton per meter. So since the distance is Y minus 1, the total load will be 4 into Y minus 1. But since it is uniformly distributed, it will act at the center of that portion, and therefore since the center is Y minus 1 divided by 2, the moment will be 4 into Y minus 1 times Y minus 1 out of 2. So if I put all those values, I will have 19Y, this will be 21Y, then minus 2Y squared minus 21, and this is equal to MYY. But remember, at the point of contraflexure, the bending moment becomes 0. So we are going to use the bulldozer method. We substitute in our values. Remember, this is a quadratic equation. Then if we use the bulldozer method it is always minus b plus or minus square root of b squared minus 4ac, everything out of 2. So that is our y. Now we know this value, we know this, we know that. So when we substitute in at the end of the day, we will have a figure that is equivalent to y equal to 1.12 meters. So this is the point of contraflexure, the point where the bending moment curve or bending moment diagram changes sign. Thank you so much. The link for the video that is showing the detailed method of section for determining the shear force diagram and bending moment diagram, I'm going to share in the description here. of that particular video. So endeavor to check it and go if you follow up from the very beginning of this video.